oops. It was going to be 6.6a, but we're going to combine them into 1 just to save a little time. So our first theorem today is triangle proportionality. We've been talking about proportions a lot. This one says if a line parallel to one side of a triangle intersects the other two sides, so we have parallel lines here and here, it's going to divide the two sides proportionally. So in other words, AB to BC is going to be equal to ED over DC. So this ratio we get right here if we have parallel lines. So using that, again, here we have parallel lines. So we can say that x over 25, wow, I'm not very good at using this thing, equals 24 over 20. So then with some simplifying, we can change it to x over 25 equals, divide both these by 4, we get 6/5. So then 5x, yes, that's a 5, is going to equal 150. And then x would be 30. Yikes. Hopefully I get better at this. Down here again we have parallel lines. So if we look here and here, here and here, we can say that 5 over 2 equals 7.5 over x. So then 5x equals 15. And x will equal 3. And then we got to solve for y. Well, the good news is we can check for similar triangles, which we have our parallel lines. So we have corresponding angles here and here, here and here. So we do have similar triangles. So you can set up a proportion with y over 6. So we're going large triangle to small triangle. It's going to equal, now don't do 2 over 5 because 2 is not a side of a triangle. But the side of this whole triangle would be 7. And then the small triangle is 5. So 42 is going to equal 5y, which you all know is 8.4. And yes, I did that in my head because I'm a genius. Ta-da! So that's the first theorem. We can do that again here. So same concept. Parallel lines, so we got proportions that are going to equal, so 2x, come on, plus, apologize for my handwriting, now you know how I feel, over 4 equals x plus 12 over 6. So make sure we distribute, so 12x, oh, come on, it's going to equal to, it's been a long day. 12x plus 24 equals 4x plus 48. So subtract the 24, subtract the 4x, we get 8x equals 24. And so x would be 3. Now we're ready for the next theorem. So converse, so it just says it goes backwards. If CB over BA equals CD over DE, then we can say we have parallel lines. So if these proportions are equal, or if these ratios are equal or proportional, that means we have parallel lines. So are the lines parallel? Well, is 14 over 10 equal to 15 over 12? Well, if we reduce them, we get 7/5, and divide them both by 3, we get 5 over 4. So in this case, no. Over on the other side, do the same thing. Is 8 over 6 equal to 12 over 9? Well, this one reduces to 4/3, and so does this one. So it works out. So this one, we can say yes. And again, the one over here, they didn't equal, so no. All right, next theorem. And again, dealing with parallel lines. If three parallel lines intersect two transversals, so here are your three parallel lines, and these two are your transversals, then they divide the transversals proportionally. So xy over yz equals uv over vw. Now you could also say uv over uw equals xy over xz. That works too. So when you have parallel lines, they create some proportionality. Finally, we can say theorem 6-7, if a ray bisects an angle of a triangle, so angle bisector right here, that it divides the opposite side, so that'd be this side, into segments whose lengths are proportional to the lengths of the other two sides. So CD over, well, we could say CD over DA equals CB over AB. You could also say CD over CB equals DA over AB. That goes with those properties we learned. So some examples, here we have our angle bisector. And we're supposed to solve for x. Well, that might be an issue because I think I'm missing a number. I'm not really sure where it went. So, well, let's just give it a number. Let's say this is, let's go with 8. So if we follow that theorem, saying this is 8, that tells us that 24 over 30 is going to equal 8 over, it's not 8, it's not what I want, 8 over x. So, simplifying, 8 times 30 is 240, and that equals 24x. We divide by 24, x is going to be 10. Not really sure why I'm writing sideways, but that's okay. Over here, well, it looks like parallel lines. We know they're parallel because our corresponding angles are congruent. So we should be able to set up some proportions. We want x, so let's go 12 over x equals, you guessed it, 9 over 15. So 12 over x, we simplify this and divide them both by 3, we get 3/5. So 60 equals 3x. And x is going to be 20. All right, now we got a lot of it. Did I skip a page? I don't think so. No. Now we got a lot of variables. We got an A, we got a B, we got a C. Got to solve for all of them. We got our angle bisector. We got parallel lines. So we got a lot of things going on. If we use that first theorem with the parallel lines, then we can say that 12 over A equals 8 over 6. So then 72 equals 8A. So A would equal 9. So we can put a 9 here now that we know what that is. Then we got to figure out B and C. Let's start with B. Use another one of our theorems with that angle bisector. We can say that 8 over B equals 12 over 6. So 12B equals 48. And B would be 4. So again, write that in here. All right, and then finally we need C. So one way to get C is to do these two, C over 7. So we're going this one to this one. So then we can add those two up, the 12 and 9, to say that's going to equal 21 over that whole side, 14. So C over 7, that's equal to 3 over 2. So finally we get 21 is going to equal to C. So C is going to be 21 over 2 or 10.5. Oops. Try that again. There we go. So found A, B, and C. We used a couple different theorems. A lot of theorems in this chapter. Or this section, I should say. So we started out on that one with this one. Didn't quite use this one because we weren't showing lines are parallel. So we didn't use that one on that one. This one, we only had two parallel lines, so we didn't use that one on that final problem. But we did use this one. And we can say CD over DA equals CB over AB. But again, you can also do CD over CB equals DA over AB. That works as well. Okay, that's just rewriting or flipping your diagonal, if you will. So you're using all those theorems today. That is going to be your assignment. As you work, make sure you're setting up your proportions, showing your work. 16 and 17 are going to take a little bit of effort. So get as much done as you possibly can, and definitely come with questions on Monday. Now, questions are ones that you don't know how to do, not ones you decided not to do. Just a reminder, please be respectful of your substitute and work the whole time. If you get done, find something quiet to do. All right, well, that's the end of the lesson. Hopefully, I made some sense there.